Hello everyone, welcome to the Education Diary, day number 1 for the natural language processing by using OpenCV. In OpenCV, it's really important to understand that what is basically OpenCV or what is normally a CV, right? So CV is something which is known as computer vision. Now in this computer vision, we are going to be having some different libraries which we are going to use and understand, right? So apart from that, today we are also going to be checking about one project, one very simple project, which is just going to give you an ideology that how actually the CV works. Now the term computer vision actually means that you are giving the vision to the machine or the computer, and you are going to train the machine, you are going to train the model, and based on all these trainings you are ultimately going to be having the vision which you have implemented to the machine. All right, so overall it depends onto the requirements, but overall you are going to be getting an ideology that how the computer vision actually works into the field of AI, robotics, or if we can also say the blockchain industry. So as usual, we are going to be working on some different libraries. We are having OpenCV, we are having YOLO, we are going to be having Tesseract, we are having OCR, which is object character recognition, we are having OD, which is object detection. So we are going to be having a lot and lot of terms, right? So as usual, I told you that in computer vision, according to the need, according to the person's requirement or the company's requirement, you are going to be developing a project. So based onto the requirements overall. All right, so these are some of the very famous libraries. So as usual, I told you that the first library is going to be OpenCV. Apart from that, we are also going to be having Tesseract. So this is also a great library which the people use for the object detection. After that, we are going to be having OCR, which is object character recognition. So this is basically object character recognition. So OCR is something on which a program can be developed on. We can train the model, like it can be handwriting or whatever, or it can be stickers, barcodes, and the program can read it directly without any human effort, right? So apart from that, we, as I told you, we are also having OD, which is basically the object detection, right? So it can be object detection, that it means basically inside a photo or inside a video we can detect the objects which are having motions, or we can train the model if it is violence or kind of like that. Suppose if there's an area, you just implement a CCTV camera and you train the CCTV that whenever it captures something which is like dangerous, it can be knife, guns, or whatever. So you train the CCTV in such a manner that whenever it recognizes something inside the frame, so it can that implement the alarm, and it can connect with the police station or whatever. So the main idea behind the computer vision is to develop some kind of things which basically helps the people or helps the machine to reduce the human effort and to do the tasks more efficiently and more beneficially. All right, so this is something which is important to understand. Nothing so deep. Today we are going to be developing one program which is just going to give you an idea that how the OpenCV actually works. All right, before that, I'm going to be having a video here which is just a video which I downloaded from YouTube. We are going to implement a CV or OpenCV project onto this particular video. You are going to be having some ideology that how we can give the vision to the machine. All right, so if I'm going here, so you can see that this is just a CCTV video in which the people are walking. So if I'm going to play this, then basically you can see that the people are walking in this particular CCTV footage. So now what I want is that I want to recognize the motion into the video, that I want some motion sensors, or not motion sensors, but I just want to have some program which can let me know that there is a motion inside a video and where are the places or positions where there is no motion. All right, so suppose if there is a car accident, so in the car accident, the CCTV can capture if a person is running from the car. So the driver has done an accident and the driver is running away. So it can basically capture the driver, or it can capture the humans, so something like that. It's just a very simple task. It's not going to be very hard to understand. So this is something I created a directory onto my desktop. I'm using a PyCharm, by the way. You just need to have this particular video into the directory, and apart from that, just ignore the other files. That is not particularly necessary right now. Apart from that, you have to go into the settings, go on to the settings, make sure to have installed the OpenCV Python headless. We are going to be having NumPy. So these three modules are really important in order to run this particular program. If you don't know how to install these, so simply go to the settings. This will be the first page. You have to go to the project and you have to go to the Python interpreter, and here you have to go to the plus, and here you can search for the modules which you want to download. So suppose if I want to download something which is name as YOLO. So as I told you that YOLO is basically one of a very great tool, auto library, which can be used in object detection or the object character recognition based on your requirements, and basically you can click on install here. Right now I'm not going to installing because it will take some time to install YOLO. Now YOLO is also having some different versions. So suppose if I write YOLO version 5, so you are having YOLO version 5, you can also download YOLO version 8, which is the recent version of the YOLO module. All right, right now I'm not going to be installing this because I personally don't need this and it will take some time to install. So in starting, you just need NumPy, OpenCV Python, and OpenCV Python headless, right? So once it is installed, we can go with the programming. So as usual, we are going to be importing the OpenCV. We are working the OpenCV, so we are going to be having CV2, right? So this is going to be something, our first thing. After that, we are going to be giving the video path. So as usual, we are going to implement our OpenCV library onto the video path, or simply we are implementing onto the video. We are not doing this on the real time. So suppose if I want to do in the real time, I can use my camera and it can basically recognize the motion into the live camera. So right now I'm not going with that, but as usual, based on to your dependencies or needs, you can basically configure the program and you can try that as well. But right now I'm implementing the OpenCV to directly to the video. All right, so we are going to be having the video path. So here basically I'm just going to give the video path. So let's copy this. Now I'm going under the copy path. You have to click here and it is basically going to be giving you the copy path. So once this particular 2 lines is being done, it's totally fine. Now we are going to be declaring a variable. So we are going to be having CV2 module. Now we are going to be having the, it's going to be, oops. All right. So now it's going to be video capture. All right, so video capture is something going to be, and in this we are going to be having video path. All right, so simple. We just give the new variable and the CV2 module is going to be running here, and it's going to be using the module video capture. That means it is going to capture the video, and the video is going to be this one. Right, so till here it's quite easy, nothing very hard to understand. Now after that, we are going to be taking foreground and background, which is really important to convert or transfer your video into the RGB or black and white or something like that, so that it can create a threshold and can give us the motion detections, right? So it's really important. It's not going to be working on the colored video, so we have to convert the colored into RGB module, and after RGB it is basically going to create the motion requirements. Of course, in the video, whenever we are trying to create a motion detection, so we have to create some boxes, right? So it is going to be having a rectangle box. So that rectangle box is known as contours into the OpenCV or into the computer vision. So we are going to be creating some contours whenever there is a motion. So there is going to be a rectangle box which is going to be covering the human motion or any kind of motion inside that video. So foreground and background. So we are going to be having CV2. So we are going to be taking create background, if I'm not wrong. So it's going to be subtract term, and we are going to be having mock2. So make sure to take mock2, not KNN, because it is going to be using the neural network. So we are going to be taking mock2 right now. Of course, by using the neural networks, it will take some lot of time. So we don't need that. We are going to be taking history. The value of the history can be 500, but you can increase, you can try. All right. So as usual, I told you that you can play with the values, and depending on to the best result which you are getting, so you can have that video or that particular program as the best. So you can try to play with the values. So I'm just taking 500 because that is something which is normal for me to take during the videos, but it can be changed as well. After that, I'm going to be taking some threshold values. So the maximum threshold value I want to take is 25 here. Once again, play with the values. If you want, you can take 50 or 100. But as usual, if in my video I want to check that is that threshold value is fine or not, so I can go with that. After that, I'm going to be taking shadows, right? So if there is a video and there is some shadows, so I can go with that. that as well. So I'm just going to take detect shadows here. All right, so quite easy, not very difficult. After that, I'm going to be taking some while loop so that the video can be played while true. So in this, I'm going to be taking some two variables, red and frame, right? So it's going to be two variables, and I'm going to be taking video dot read, right? So it is basically going to read the video inside my particular program. Quite easy, not very difficult. So after that, so I'm going to be having if not red. So suppose if there is no contour into the video, if there is no motion, so it is directly going to give the exit value. But if there is a contour value, so we are going to add the boxes there. All right, so if not red, I'm going to be taking break. Simple, no issues in this particular program. Now I'm going to be adding an foreground mask, which is going to be having the value, or we can declare this variable with fg mask, and I'm going to apply this as fgbg, and dot I'm going to be apply what, frame. All right, so I'm going to be applying this particular variable which we already declared. So here you can see that we already declared this particular variable. Now as usual, if you don't know Python, so it's going to be hard for you to understand, but if you know Python, so it's going to be easy for you. Now I'm going to be having another variable which is going to be contours, and I'm going to be having dash, and let's take this one below one. All right, so we are going to be having cv2. So we are going to be having some fine contours module. So we are going to be having fine contours modules, and inside this, as usual, we have to declare the fg mask, the very first thing. Parameters, so these are basically the parameters. So cv2 dot, we are going to be having retr list for external. So there should be retr external. All right, so make sure to use external because contours are always made externally, not internally. All right, so after that, we are going to be having cv2 dot chain. So we are going to be taking a proc simple. So it is going to create a very normal contour box, but if you want to design some contours, so you can use that as well. Right, after that, we are going to be having for contours. We are going to be having, let's take for contour in contours. All right, so let's take this. So this is not going to be a very huge program. It's just going to be around 20 or 25 lines. So suppose if I'm going to run the program right now, so as usual, there is something which is not working fine. So of course we have to declare the blocks also inside that. So that's why the program is not running right now. So let's declare first of all this, and after that, I think so the program should be running easily. So if cv2 dot, we are going to be taking contour area once again. So we are going to be declaring the contour. So suppose if this is something smaller than 500, which was the value above, so it is simply going to what, continue. So this is something which is based on frames by frames. If the value of the contour is less than 500, then the box will be continued to the next frame and so on. But suppose if the value is more than this, so it will basically break or end, right? So now we are going to be making some boxes because we have to create the boxes. So for boxes, we are going to be taking four variables, x, y, w, and h, which is a universal variable parameter, which we always take. So cv2 dot, we are going to be having some bounding, right? So bounding rect, which is the rectangle, and inside this, I'm going to be having contour. All right, so quite easy. After that, I'm going to be creating the rectangle. So I can take basically rectangle here. Now inside this, we should be having parameters. So first parameter is going to be our frame. After that, let's take x comma y, right? After that, we can take x plus w comma y plus h. So this line is universal. All right, so it's very important to murmur some of the lines. So some of the lines are universal in the field of coding, so you don't need to remember or you don't need to find the logic behind that. You just try to murmur that. So 0, by the way, you can play with these values. All right, again, as I told you. So at the very last parameter, I'm going to be taking 2. So I think so this is fine. And now at the very last, if I want to check, suppose if I'm going to run this particular program, I think so it should run now. if I'm not wrong. So it's running, but it's not giving us any value, right? So it's not giving us any value right now. So what I can do is I can move forward. All right. So if I'm going to be having here, for an example, if I want to check if my program is running or not, so I can just use this particular command here, and I think so it should show now. If it's not, so we can proceed forward. All right, so everything is working fine, but the video is not showing. So we have to check the video, right? So let's declare the video now. So we have the rectangle. Now we are going to be creating some motion sensitivity if we want. I'm taking another variable, motion sensitivity. So just ignore some spellings, all right? So don't worry for these spellings. It's not English class. So motion sensitivity is going to be something which we are going to be taking cv2.contour area again. And inside this, we are going to be declaring contour. So we have to give some sensitivity parameter. So suppose in a video, if there is a box, and if I want that, what is the motion sensitivity of that human or of that particular person inside the video? What is the sensitivity of that person from frame to frame? All right, so as I told you that the video is a frame thing. There are 30 and 60 frames or 90 frames per second depending on the video. So based on to the frames, I want that what was the sensitivity on that particular moment, and after 2 steps, what is the sensitivity of that person into the second frame. So I'm going to declare this also. So suppose if I want to label the motion sensitivity, so I'm going to be taking F, inverted commas, and I'm going to be having motion. All right, so inside motion, I'm going to be declaring the int values, which is of course going to be something, the integer values. All right, so here I'm going to be declaring the motion sensitivity. Quite easy, I think so. Everything is fine in this line. And after this, we are going to be having cv2 dot put text. So we are going to be putting the text of the frame. So we are going having frame, and we are going to be having label, and in label we are going to be having the values. Let's take x comma y minus 10. So you can take again minus 20. Like this is the size of the characters, the font which is going to show us above the box. So you can take y minus 20 or y minus 30 depending on your need. So y minus 10 is fine for me. I can take another parameter which is going to be the font which I want. So I can go with the cv2.font, and we can go with Hershey triplex, or you can take plain if you want. I can go with the simplex also, which is just a simple font. All right, so after that, I'm going to give another parameter which is going to be the size of this particular font, which I want should be 0.5, and the last parameter is going to be again 0.255 comma 0, and this is the color of the font and the thickness of the font. All right, so now we just left with 3 or 4 more lines, and after that the program should be working really fine. So we are going to be taking cv2.imshow, which is the frame, and inside this I'm going to be having a motion detector. So this is actually going to be shown above the box, motion detector, and after that it's going to be frame. All right, so now the very last, if cv2.wait key. So let's take this 10. All right, and we are going to be having 0x ff equal to, let's take the order q. Like suppose if I press q, then the program should stop working. All right, so break, let's give the break, that means quit. But apart from that, I think so everything is fine. I can go with the video release, and at the very last we are going to be having cv2 destroy all windows. So by the way, this is just 34 lines of program, and once you execute this program, you can see the boxes. So suppose if I run the program, so here you can see that we are having the boxes of the, like, around the people, and it is basically showing us the motion of the people. But the problem is that the video is really fast. We cannot check out. So what I can do is I can go in the down, and here let's change the value of this to something 200. So the video can be very slow, and we can check also that how the video is running. So now here you can see that there are some places on which there are no boxes, means we are not training the model, right? So we didn't train the model onto the human motions, but if we are going to train the model, then the model is going to be working more fine, more perfectly. But this is just an idea that how the computer vision actually works. Here you can see that the motion of the person is changing, like the motion of every person is changing, previous frame and the forward frame, like the past frame, present frame, and the future frame. So the motions are labeled on every contours. So as usual, these are the contour boxes on which the motion parameters are being mentioned on. So here you can see that on some, it's basically, if it's less than 100, then the motion is 90%, 70%. But if a person is really fast, as usual, the video is really fast, so it's going to be having the values into the thousands, or it can be 5,000, 4,000, right? So this is actually something which you can play with. You can detect the people or the motions inside a video, and it's really a fun project which you can work on, which you can do. It's not really hard to understand about the OpenCV. It's quite easy to understand. Now the mathematics, or like, suppose what I want to tell you is that, suppose if I'm going onto this folder so that I can show you the images, which is really important to understand. Now this motion sensitivity across frames is something which you need to understand. All right, so suppose, as I told you, that if it is less than 100, then there is no motion, then there is something which is not having any parameter. But suppose the frequency is changing of a person by time to time in every frame. So here you can see that within 0 and 10, within 10 frames, the person is having the motion, like it is basically having 25 to 2, then it is having to 3250, and the motion is changing between the 10 frames. After the 10 frames, the next 10 frames are having very low motion, and after these 10 frames, you are going to be having high motions, and based on different frames, you are having some different motion sensitivity. All right, so this is really important. The mathematics is really working behind the scenes, so you have to understand that the motion is based onto the frames. If the frames are high, the motion can be high or can be low. So depending on to the frame video, it can be 30 fps or 60 fps, or depending, right? So as usual, it depends. Now apart from this, what I want to show you is the another graph, which is telling you the distribution of the motion sensitivity. Now as usual, this is just telling you the frequency and to the contour area. So as usual, the contour area is like the frequency. Suppose if the motion is more than 4,000, then the contour area is basically creating a 500 of the box, so 1,000 of box, and like in the middle of that. So this is basically telling you about the distributions of the motion sensitivity across different frames based on to the frequency, right? So I think so you really enjoyed this particular project, but for me the project was really good, and it is just an idea which is just telling you what the OpenCV, or what the power computer vision can have. You are having multiple libraries. As I told you, you can work with YOLO, you can work with Tesseract, you can work with OCR. Right, so here you can see that I'm already having YOLO, and previously I was working on the YOLO. Now here you are basically creating, you are training the model, and you can actually see that I just used the CPU process, not the GPU. But when I train my model, it basically have 100 epochs. So if you can see that, here is the epochs value. And it basically took around 59 hours to complete this particular process, and my laptop was on. But if you're having a GPU, even though I'm using MacBook, but still it is going to take a lot of time for training up the model, and ultimately the size of the model is just going to be 5.3 MB. So here you can see that the 100 epochs completed in 52 hours. So that is something which really depends. If you're having a CPU or a very great GPU, then the process can be really fast for training the model. Otherwise, it's going to be really hard to just work on your CPU. Of course, if you're going to be having Windows, then it's going to be more and more hard. All right, so this is something which I personally did. So YOLO version 5 I was using, but you can work and you can go with more and more particular libraries. As I told you, Tesseract, OCR, YOLO, you can work with TensorFlow, Keras, PyTorch, PyVisions. So there are tons and tons of libraries through which you can work on. I hope so that you really enjoyed today's webinar. And if you're going to be having some queries or questions, you can just email to the education diary. If you're going to be having some doubts, you can just comment down below. And thanks everyone for watching up this webinar. Thanks a lot, and have a nice